Hello everybody, and welcome back to Kids for Code. Today we're going to be learning about searching arrays. So let's review the summary questions from last week. How can we manually manipulate an array? We can change the value inside of an array using indices, using array, and the square brackets I and then n square brackets. So I is the index that you want to change, and you can just set that equal to the new element that you want in that index. What does name of array.length do? It tells us the length of the array, which is how many elements it can store. How would you make a copy of an array? First, you make a new array that's the same size as the old one, and then you use a loop, and you manually set every element of the new array to the elements of the old one. All right, first we're going to learn about linear search. It's the obvious way of finding something in an array. We start at the front and check each element until we find the one we're looking for, or we get to the end without finding it. We're not going to be dealing with not finding it today. It's called a linear search because it is linear. It starts at one end and checks each element in order. This is what you use in the find element project. We didn't tell you as linear search. For example, we're going to search for 7 in this array of length 5. We start out at index 0. We find a 1. 1 isn't 7, so we keep looking. Index 1, we find negative 10, but that's not 7 either, so we keep looking. Here at index 2, we find a 3, but 3 isn't 7, so we keep looking. And here at index 3, 7 is 7, so we found what we're looking for, found it at index 3. All right, now we're going to program linear search. So open up Eclipse. I'm using something different that does the same things that Eclipse does. Make a new project. In your new project, make a new class and call it searching. Inside of searching, you're going to put some code to help us get started. All right, this right here. So you can pause the video now to put this in if you like. All right, now we're going to implement the linear search function. So for linear search, we have a loop that goes through each element of the array until we find the target. So we write a loop. We're going to start at 0 to start at the first element. We go through all of them, so we want to wait until we got into the length to end the loop. We want to go through each one individually. So we go plus plus. All right, so I'm going to check if the element at index I is the target. Then you want to return the index that the target's at. You're going to get an error if you try to run it right now, because Java knows that you might end this for loop without ever finding the target. I'm just going to say return -1 for now. You don't have to worry about this, though. This will never actually happen in our code. All right, so then in main, you're going to add a new line. All right, so you want to print out the results of the linear search. So you're going to go through this array we already made, and let's search for 8. So 8 is right here at index 0, 1, 2, 3. So this should print out 3 if it works correctly. So let's try running it. Oops. And there, we get 3. The linear search worked. This is binary search. It's a faster but more complicated way to find something you're looking for. But to use it, the array has to be sorted. That's really important. It's not going to work if the array isn't sorted. So how does it work? It searches through the array by repeatedly dividing the search in half until the target interval is found, until the target value is found. So first, it finds the middle of the array and checks if that value at the middle of the array is less than, greater than, or equal to the value that we're looking for. All right, if it's equal to, that's great. That's what we're looking for. We're going to return that index and be done. If it's less than, we can ignore the right half because we know it can't be bigger. This is a sorted array, so it must be on the left. If it's greater than, we can ignore the left half of the array and just check the right half of the array. Again, it's sorted, so we know which side it has to be on. We're going to keep on repeating step 2 until the target value is found by going to the middle of the new part of the array we know it's in and checking if it's bigger or smaller, and then cutting that section in half. So with binary search, we need a way to find the middle of any part of an array. We do that using this formula right here. We plug in the minimum, which is the smallest index that the value we're looking for could possibly be in, and the maximum, which is the largest index the thing we're looking for could possibly be in. We divide it by 2. These weird L things mean round down. So fortunately, with Java integer division, it'll do that for us automatically because these are both integers and 2 is an integer. We don't have to worry about rounding down ourselves. All right, let's do an example. We're going to search for 4 in a 5-element array. There's 5 elements. Okay, so we're going to start out, it could be anywhere. We don't know where it is yet. We haven't cut it in half yet. So we're going to say we can start from the smallest possible index here to the largest possible index here. We're going to do our little equation. 0 plus 4 divided by 2 is 4 divided by 2, which is 2. So 2 is in the middle. So we're going to check index 2. The element is 10. 10 is greater than 4, so we know that 4 has to be to the left. So we're going to just ignore these elements now because we know it can't possibly be here. We're just going to look at these 2. So going back through our function again, 0 plus 1 divided by 2 is 1 divided by 2, which is 0. We're going to look at 0. And look at that. Element at index 0 is 4, which is 4. So we found it at index 0. All right, let's do another example. We're going to search for 17 in a 32-element array. So again, it could be anywhere. We haven't cut it in half yet. And using our little formula, 0 plus 31 divided by 2 gives 0 and 31 is 31 divided by 2, which is 15. So we're going to start looking at 15. That's 8. 8 is less than 17, so 17 has to be over here. So we can just ignore all of these, move this over here. So it's after index 15. So plugging in our formula again, 16 plus 31 divided by 2 is 47 divided by 2, which means we're going to look now at 23. So if the element at index 23 is 15, that's still less than 17. So we can ignore all of these because we know 17 has to be over here. We update this again, move these over. All right, so now it's after index 23. Using our formula, 24 plus 31 divided by 2 is 55 divided by 2, which is 27. So the element at index 27 is 18. 18 is bigger than 17. So you know that 17 can't be over here. It has to be over here. So we ignore all those elements. Move where it could be. All right, so for our fourth step, 24 plus 26 over 2 is 50 divided by 2, which is 25. So we're going to look at element 25, and look at that, it's 17, which is what we were looking for. So we found 17 at index 25. All right, now I'm going to program the binary search. This one's a bit more complicated. Let's go back to your searching Java file. I'm going to uncomment this line, just move the 2 slashes in front, and start programming it. So in the binary search, there are 2 things we need. We're going to have a minimum and a maximum. So these are indexes. So the minimum index to start out is 0, because it could be at the very start, we don't know. So the maximum it could possibly be is the array to search length minus 1. Minus 1 because the length isn't actually a valid index. Minus 1 is the biggest index possible because it could be at the last index. We don't know for sure. All right, so now we're going to do a for loop. Sorry, we're actually going to do a while loop. We want to know while the min index is less than or equal to max index. So this condition is a little bit complicated. It has to do with when it's not actually in the array. So you can ignore this for now. Just know that's what you have to put in here. Okay, so inside of a while loop, we're going to calculate the middle. We're going to find the mid index equals min index plus max index divided by 2. That was our little formula that we used to find the mid index. All right. Now we want to find the middle element. So mid element equals the array to search at the mid index. So that's the element that's in the middle of the array. Now we're going to see how it compares to the target. So if our target is the mid element, and we found it, we're going to return the place it was found at, which is the mid-index. All right, maybe it wasn't that though. So if the target is greater than the mid-element, that means the target comes after the mid-element. So we can ignore everything that comes before. To do that, I'm going to change the minimum index to be the mid-index plus 1 to ignore everything that comes before the mid-index and everything at the mid-index as well. Now, if the target is less than the mid-element, that means it must come before. So now we can change the max index to be the mid-index minus 1. That way we say everything that's bigger than the max index can't be it, and the mid-index can't be it either. Great. So now the last thing we have to do is right here, same error as last time. Let's type in return -1. We don't need that. That's just in case you don't find it, but we always will. Okay, so now up here, you copy this line sort of, change this to binary search, and make sure that this also gives us 3. You can see down at the bottom that it does. Both of these print out 3, which means they both found it. So you can try changing our target if we want. We want to find 3, it should be at index 1. It does print out 1. Maybe we want to find 10. 10 is at index 0, 1, 2, 3, 4. So it should print out 4. And it does. So our linear and binary searches are working great. And yeah, we can keep moving on. Which one should we use? Binary search is always faster than linear search, but the data has to be sorted in order to use it. Linear search also compares equality, whereas binary search compares order. So data has to be able to be greater than or less than. For example, ints, doubles, and strings can be put into order. Integers and doubles, just negative numbers are smaller than positive numbers, and 0 is less than 5, and strings can be alphabetized. But some things just can't be compared like that. So our summary questions. How does linear search work? How does binary search work? What kind of arrays can be binary searched? Which is usually faster, binary search or linear search? We're going to answer these summary questions in the next lesson. You guys can answer these on your own for now. All right, bye.